The problem statement, the biggest problem found was the need to update the current wireless access points from 802.11g to the newer 802.11n, which is becoming increasingly more popular due to the newer technological devices that are being introduced now and in the future. Wireless N is the very latest wireless networking technology and is the best choice if you are using your connection for streaming media and or heavy traffic of downloads and uploads. 802.11n wireless adapters only work optimally when connecting to an 802.11n system. The biggest benefits of updating to the 802.11n is Wireless N's multiple in, multiple out, or MIMO technology, which multiplies the effective data rate. The other added benefit of 802.11n is the ability to take advantage of the 5.8 GHz channel capacity. Therefore, it is more practical to operate a mixed 802.11 BGN network in a mixed mode system. It's generally best to use a dual radio access point and place the 802.11 BG traffic on the 2.4 GHz radio and the 802.11n traffic on the 5 GHz radio. Some of our wireless network requirements that we're looking at. Some of the major requirements for determining how to set up a wireless network in order to obtain the maximum performance are: you want to achieve the best possible WLAN performance, you want to optimize network performance for a variety of applications, data and voice, minimize co-channel interference, determine the quantity and best locations for access points, and verify post-installation that the WLAN performs as designed. And you want to fully document the entire network for reference and future verification purposes. The wireless network life cycle begins with the pre-deployment and expansion planning phase. It moves on to the installation and verification, and then it goes to troubleshooting, and it'll end up with management and optimization. When planning a WLAN, there are many things to consider. Coverage areas must be sufficient to meet customer requirements, and there needs to be enough signal overlap from adjacent access points to ensure you don't lose your connection, but not so much as to cause significant channel interference. In addition, there usually will be requirements for total throughput, throughput per user, and signal to noise ratio. Moreover, the deployment should stay on time and on budget. After conducting the RF site survey, it was determined that there was a high amount of congestion in the 2.4 GHz channel area. It is my recommendation to upgrade to the 802.11n wireless access point in order to take full advantage of the 5.8 GHz channel area. Some of the financial requirements for the wireless network costs, you're looking at wireless router, wireless LAN, and wireless access points. Network server wiring cabinet, and network management network security software, for a grand total of $30,801.70. The time requirements. Another requirement involved with this project is the time that's involved in removing the older 802.11g wireless access points and replacing them with the newer 802.11n wireless access points. It will involve a coordinating effort with the university's maintenance department and the information technology support unit as well. I feel the new wireless access points can be installed in one day's time as long as the maintenance department and the information technology support unit can perform their relative operations on the same day. However, it may take up to 2 weeks to recable the new network server wiring cabinet and install and configure the new software that will be used. For the SLA, or Service Level Agreement, it's simply a document describing the level of service expected by a customer from a supplier, which lays out the metrics by which that service is measured, and the remedies or penalties, if any, should the agreed upon levels not be achieved. And from the customer service statement, the IT support unit is committed to delivering customer service by striving to ensure customer satisfaction, responding to requests for support within published time frames, interacting with faculty, staff, and students in a courteous manner, and requesting feedback for opportunities for improvement. The IT support unit services that you'll be in charge of is computer disposal, data network and infrastructure, database management, desktop hardware and software installation, hardware and software inventory, information systems, application development and reporting, internet access, network security, network storage, printer setup and maintenance, remote access, server storage, technology consultation, technology installation and maintenance, VoIP telephones, and website development and maintenance. The SLA priority levels, you start out with low, which is a service request that does not require immediate attention or involve long-range planning. And the response time for that is within 3 working days, with a completion time within 5 working days. And then that goes up to medium, which is a general service request or problem with workaround solution, with a response time within 8 hours and a completion time within 2 working days. And then that escalates to the high priority, which is a problem with no known workaround that affects a single user, with a response time within 2 hours and completion time within 1 working day. And after you go from high, it escalates to the very high priority. And that is a problem that affects the entire university, community, or a group of users, with a response time within 1 hour and completion time within 4 hours. The network security software we're going to install is the Zone Alarm Extreme Security Suite. It offers advanced download protection, operating system firewall, virtual browsing, antivirus and spyware scan engine, and secure online backup. The network management software is a Manage Engine Op Manager. Is a network performance monitoring, server performance monitoring, easy installation and setup, application performance monitoring, and network fault management. Here you can see the Murray State University Curris Center's management architecture map. From the office you have your computers, and they go out to the router, which goes to the gateway. Then it goes through the firewall out onto the internet. And here's the network design map of Murray State University, including Murray State University's Curris Center. As you can see, the wireless access points going out from the router out onto the internet. Here's the floor plans of the Curris Center. In the first floor, there's 6 access points distributed. On the second floor, there are 4 access points. And on the third floor, there are 4 access points as well. And that is also the same floor that stores the network server wiring cabinet. And that's also where the switches are. We did a wireless in access point comparison where we compared our 3 comparable wireless in access points that we could deploy. And it offered the Cisco AeroNet wireless in dual band access point, the Linksys dual band access point, and the D-Link wireless in dual band access point. The Cisco AeroNet featured the first controller-based access point to create a self-healing, self-optimizing wireless network, whereas the Linksys adds wireless capability to your existing wired network or upgrades older wireless networks to the wireless in performance. The D-Link allows administrators to deploy a highly manageable and extremely robust dual band wireless network, where all 3 dual band antennas are detachable and can provide optimal wireless coverage. We then did a wireless in access point evaluation, where we evaluated our top 2 selections, and that was between the Cisco AeroNet and the D-Link AP Premier. The Cisco AeroNet features automatic interference mitigation for better reliability and performance, remote troubleshooting for fast problem resolution and less downtime, and robust security with non-Wi-Fi detection for off-channel roads. Whereas the D-Link Air Premier supports Wi-Fi multimedia quality of service features. It also supports load balancing features to ensure maximum performance by limiting the number of users per access point. And in the end, we found, after comparing those two wireless LAN access points, we decided to go with the Cisco AeroNet. It includes clean air technology for automatic interference mitigation, helps enable remote troubleshooting for fast problem resolution and less downtime, delivers comprehensive security with the industry's first access point to provide non-Wi-Fi detection for off-channel roads. It enforces policy with intelligent identification of wireless devices, and policy enforcement with customizable alerts prohibit devices that interfere with the network. It offers auto band select, which improves 5 GHz client connection in a mixed client environment. It also offers video stream, which uses multicast to improve multimedia applications. And of our network device list, we'll be using the Cisco AeroNet access point, Cisco Catalyst 6509 switch, and Rack Solutions network server wiring cabinet. As far as our project schedule, we have maintenance doing removal and installation of the new wireless access points. Then the Information Technology Support Unit will configure the new wireless access points and remove the configuration of old ones. They'll also remove cabling from current wiring cabinet, and the maintenance department will then remove the old wiring cabinet and install the new one. The Information Technology Support Unit will install cabling into the new wiring cabinet. They will install and configure new network management software. Then they will install and configure new network security software. And once you get where you have less traffic congestion or no traffic congestion, as you can see, all connected, you have your signal now. And that concludes the end of my presentation. Thank you.